Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, for those new to the show, my name is Sean Tierney from Insights in Automation, and each week I invite a new vendor or customer or user on the show to talk about products, technologies, and solutions. And if there's any graphics, this is more of an interview style recording today, but if there's any graphics, we would always call those out for those of you who listen, because we know over a quarter of you, even on YouTube, listen to the show and not watch it. And so we appreciate you all, whether you're listening or watching. And with that said, I do want to thank our sponsor for this episode, theautomationschool.com. They are making this production of this episode possible. So if you need PLC, HMI, or SCADA training, please visit theautomationschool.com. If you have any questions about the training there, just reach out to me because I'm the instructor. So with that said, today we have Drew on the show. I'm looking forward to talking to him about a wide variety of topics, but because it's Drew's first time on the show, I'm going to ask him, Drew, if you don't mind, could you please introduce yourself to our audience?
Sure. I am Drew Allen. I'm the CEO of Grace Technologies. I took over in January of 2021. Our history, kind of family history, is quite lengthy in the automation space. My grandpa was a regional sales manager for Allen Bradley in the 70s and 80s for Los Angeles. My dad is a former Rockwell guy as well. I did not follow in those footsteps. But I started going to China with my dad at 13, which gave me kind of a really interesting viewpoint of how products get made. And after living overseas for a while after college, I ended up kind of moving back to Grace, took over a lot of sales roles and responsibilities, and then kind of culminating in taking over as CEO in January 2021.
Well, congratulations on that. Anybody who's a regular viewer of the channel knows that over the last 12 years, we've covered Grace, especially on the news shows, some of their technologies that they've come out with over the years. And you guys all know me being a former Rock Automation certified specialist. I was working for distributors. I was, came across Grace quite a bit, and they're always at all the big shows as well. So if anybody's going to any of the upcoming shows where Rockwell will be at, you'll probably see Grace there. But in any case, Drew, I want to thank you for coming on. And that is an interesting background. I know we have a lot of things we want to talk about today. Before we jump into that, though, could you give the audience the website for your company?
You can find us at a couple different URLs, but main one would be www.graceport.com.
Okay, great. That's the one I always remember, but that's actually not the name of the company. But I think a lot of us came to know your company through those bulkhead connectors, which are so user-friendly. If you need an Ethernet jack, you don't want to open up the enclosure and you're right there with it. But you guys do so much more than that. In any case, I did want to start our conversation off talking about safety by design. And you guys have so many different products that deal with safety, right? So seeing, is the panel hot or cold, right? Just from the outside, just looking at the outside of the panel, we don't even have to open up the panel, of course, if we have the bulkhead connectors and so on. But what can you tell us about safety by design here in the 2020s?
So I got three different threads I want to pull on. Okay. So first, safety by design really came to be as part of NFPA 70E, I think about 10 years ago, in one of probably the 2013 or 2010 revision. And they started to put a safety by design section into that 70E document. And that was really the first time of like thinking, maybe we can actually make equipment safer for the electrical worker. And, when we kind of saw that, it also played into, it played in with this thing called the risk control hierarchy. And so the risk control hierarchy, is this pyramid, right? And at the top of the pyramid, you can eliminate the risk. The second is kind of substitute a lower risk. Third would be engineering controls. Fourth would be admin controls. And then fifth is PPE. Now, oftentimes in an industrial facility, what we jump to first to protect the electrical worker or the technician is we jump to PPE as really the first line of defense, where 70E really says you should start at the top of that pyramid and reduce and eliminate the risks as really the top kind of order of control. And that actually lines up with a lot of our experience in the industrial field and kind of gets into a little bit of the genesis story of Grace. So Grace actually started off as Grace technology started off as Grace Engineering and Integration. And we were a Rockwell system integrator. And we were working on a friction fit welder retrofit for John Deere. And the guy at John Deere was tired of reaching his arm around 480-volt bus bar in order to access the Slick 500. And he goes, can you just like create like a port on the outside of the panel that I can plug my laptop into to be able to access the PLC? And my dad has this pretty stringent no-nose policy. And he's just one of these guys who will always figure it out. And my dad's like, sure, we'll figure it out. So he goes ahead, creates a prototype, and delivers the prototype. And then 2 weeks later, the customer calls up and goes, hey, can I get another one of those Grace ports? And that was kind of like the start of the product line. And so we actually kind of started doing safety by design without any sort of theoretical NFPA 70E backbone, because 70E was not a thing back in 93. I think maybe it was technically a thing, but no one knew about it. NFPA 70E actually started as an offshoot of the IEEE PCIC committee, PCIC being the Petrochemical Industry Conference. And DuPont DuPont and some of the other petrochem companies had a big hand in kind of starting to assess this arc flash risk. And so when we look at a control panel from an electrical safety perspective, we're typically looking at two specific risks. We're talking about shock hazard as well as arc flash. If most people I talk with have had some sort of exposure to shock, a lot of people still are surprised to hear about arc flash. Now, people who have experienced an arc flash, they're evangelists for keeping people safe. And so we, at Grace, we really have tried to come up with solutions that keep people outside of that cabinet.
If you or somebody you know needs training on compact logics, control logics, or really virtually any Allen Bradley programmable controller released over the last, say, 40 years, then I want to share with you what I'm working on right now for release in early 2026. And, if you've been following me, you probably know I release a new course every year. But for 2026, I decided that I was going to refilm all of my Allen Bradley PLC courses and release 2 new courses on the Legacy PLC 5 and Slick 500. And this all came about as I'm here in my physical training room in the Berkshires working on new labs for 2026 for the in-person courses. I'm like, this is the perfect time to update all my Allen Bradley online courses. So if you are already enrolled in one of my level 1 and 2, or what I call my extended courses, just know that you're going to get these new courses completely free of charge. And if you ever bought a mega bundle or ultimate bundle, that's what comes in those courses, are the extended editions. So you're going to get the new courses completely free. And if you're a new student who comes in and buy the new course, you're going to get the old one as well. And I'm doing this for those people who maybe they're servicing old control logic systems with ControlNet and they're using like version 20 of the software. Well, it looks a lot different and operates a lot different than what version 31 and above does, right? So in any case, I did want to share that with you. And again, if you know anybody looking for either in-person training or online training, please send them my way. And with that, let me get you right back into this week's episode of the Automation Podcast.
In UL NEMA land, a big difference is between UL NEMA and IEC is where the safety protection is, right? And so in the US and in Canada, we consider the enclosure kind of the main mechanism for ingress. Whereas in Europe, the device itself, so like a contactor itself, is designed to actually have the ingress. There's upsides and downsides with kind of both approaches, but ultimately, we figured we're going to try to keep people outside of the cabinet as much as we can, and keep people away from voltage, and that was really how we started. So our first product line was Graceport, and what we figured out very quickly was we would create a standard number of SKUs, and then we would get asked for another SKU, and then we get asked for another SKU. Well, today we're up to like almost 20,000 unique combinations that we've created. And we just really innovated, and we can build and ship a brand new gray sport that we've never created before in 2 to 3 days. And we just have really, really fast lead times. So we found that engineers really want what they want very quickly.
Yeah.
And so we just wanted to be super easy to do business with. Just configure what you want. We'll build it for you. We'll ship it out as fast as possible. And that was really kind of our claim to fame and our initial product line. And so you've got this kind of convenience and safety play, right? The other thing is if you're a engineer, you don't necessarily have to have an electrician standing by because the door is not open. Whereas often, so your payback period on a gray sport is pretty dramatic and extreme. Imagine you have an 8-hour kind of troubleshooting or programming session, and now you're able to do it with one guy instead of one guy plus a electrician standing by. Not really. I mean, I love electricians, but you're not adding a lot of value at that point of the process. So that's kind of the gray sport.
Yeah. Go ahead.
Go ahead.
No, I was just going to say, I think we all have seen them. I know if anybody out there, if you're using Rockwell, you've probably seen them. And, as technology has changed over the years, more USB-C, more Ethernet, you still need power in a lot of cases to plug your laptop into. But, I think, starting maybe 25 years ago, I started hearing as a PLC guy, I'm like, arc flash, what's that? But it's a serious thing. And I know my customers I work with in plant, they all had to go through the training, and it was serious, and they all had to line up, and my sales guys were all over the PPE and trying to make sure they had the right vendors to sell the right products to the right end users. And it was a huge deal, and a lot of people actually changed their products. It's MCCs and VFDs, those products actually changed to mitigate arc flash and to try to add layers in there to protect those who may open the door to the MCC. So there's a protective layer between them and the bus, and it just really changed our world. And I think safety first, right? But if you can do something where you don't have to get all your PPE on, right, and you can actually work on your control system, whether it's putting the controls in a separate cabinet or having other things. A lot of times you can't avoid that with a high horsepower VFD. You can't put it in its own little small enclosure. It needs to be in that big enclosure with the 480 volt or whatever. And there's a lot of current there that could in certain cases cause problems. That's why I always love, and I got to say, I think it's Bernie and Les is the cartoon, which I just love. If you guys have never seen that, you got to go to gracepod.com. It's a great comic strip series that shows like kind of the old ways of doing things and the new ways, and then the funny ways, which nobody would do it. Like people standing on top of people and silly things like that.
Well, so you want to know the genesis story of that?
Oh yeah, please. Yeah.
Okay, so we were on a family vacation, and the company had kind of just started up, and at the time it was just being an entrepreneur, right? It wasn't like startup go raise money in the 90s type of situation, right? Especially in the Midwest. And so Dad was having a hard time communicating what the gray sport did, right? Like it allows you to connect to the PLC on the inside of the cabinet, like through the outside of the cabinet. Like it was a hard thing to describe. And so he ended up picking up a comic, like how to draw a comic. And so he ended up actually creating this, like kind of this guy, like on an operating table with like a port on his belly, and like wires and, and there was a couple more revisions of that. Dad actually is a relatively good, he's relatively good at drawing. I've told this on a couple other podcasts as well, but my great grand uncle on my dad's mother's side was Samuel Finley Breeze Morse, who invented the Morse code. And so everyone knows him for that, but he was also like quite an awesome artist. And so there's kind of like this thread of like art and design kind of in my family. And so Dad got that gift. I did not get that gift. But anyways, he kind of started this drawing thing, and he finally figured out like a really good cartoon. And so he ended up putting that up on his displays at Automation Fair. And so people would come up and say, well, what do you do? And he was just able to just point at the display. And that was really like one of the first big kind of like marketing things that we figured out was like how to communicate that message. But but yeah, we have Bernie and Les. They're getting into trouble all the time, and they're really fun. We have an entire Slack channel where everyone in the company kind of like submits ideas. So I would open that up to your listeners of like, if you guys have ideas of what you think Bernie and Les should get in trouble with, like give us some ideas, and hopefully you can learn from their mistakes.
Well, and I think a lot of the episodes have to do with and I'm going to say this wrong, but PSEDs. Can you
P-
explain that a little bit?
yeah, PESDs. So we start with the Graceport, and for product businesses, the hardest kind of crossing the chasm is going from being a single product business to being a multi-product kind of family business.
Yeah.
And we knew that there was additional ways for that we needed to protect workers. And so we kind of started doing some research, and we ended up figuring out that, hey, we need to alert people that voltage is really inside of this cabinet. And so about 15 years ago, maybe a little bit longer, we ended up releasing the R3W, which is our voltage indicator. And that was our first kind of, foray into the voltage indication space. And a lot of our growth has now come from that PESD business, and we've come up with a lot of different variations. There's really three different flavors of products. We have our voltage indicators, which are really for voltage presence. That addresses the need for the mechanical worker in addition to the bump, try, or jog test, whatever your terminology is that you guys use in your facility. Everyone knows, I mean, you're a PLC guy, right? So when you are pressing a green push button or a green button on an HMI screen, you don't exactly know what you're testing. If there's a permissive in the system, maybe there's an interlock that's open. You don't have a good sense of what you're testing. But OSHA does require you to do that bump test, that try test. It's just no one would trust it. And that was really the initial kind of foray was let's provide additional verification for the worker that, hey, there's power present or not there for mechanical lockout tagout means. And then we started getting, how can we do full electrical lockout tagout without opening up the panel door? Now, when I say electrical lockout tagout versus mechanical lockout tagout, let me define those. Mechanical, first of all, there's a lot of different lockout takeouts. You've got mechanical, electrical, thermal, gravitational, hydraulic, pneumatic. There's, I think, nuclear lockout takeout actually as well. So there's a lot of different types of lockout takeout. Mechanical lockout takeout is really my hands are not going to come in contact, or I'm not going to enter the arc flash approach boundary of that piece of electrical equipment. So I'm doing mainly mechanical work. Maybe I'm changing out a bearing or something like that, or clearing a jam in a machine. For electrical lockout tagout, it means I'm entering into the arc flash approach boundary of the electrical equipment. I'm also likely going to be putting my hands on conductors, and that really requires that kind of jumps over from really an OSHA standard to NFPA 70E. And 70E Article 120 requires a live dead live check. And so we figured, how can we do this? And we ended up partnering with a company called Cintas. Little known fact about Cintas. I believe this is still true, though. I think Amazon's giving them a little bit of a run for their money. Cintas has the fourth largest fleet on the road. They're the world's largest industrial laundry business in the country. And unfortunately, they had a pretty serious fatality in one of their facilities about 15 years ago. That really changed the way that they started, that really changed their culture of safety in their across their company. And it was due to a lockout tagout mistake. And so they decided we got to get serious here. And so they reached out to us, and we actually ended up co-developing a voltage indicator kind of on the left side, and on the right side, we came up with safe test points that allowed them to do a fully metered test outside of the cabinet. And then that kind of ended up morphing into our safe test point offering. What's cool there is we put 102K ohm impedance on the back end of that circuit. So at 480 volts, you're limited to about 2.3 milliamps of max available current, which is below OSHA's definition of a shock hazard, as well as you're below any sort of arc flash hazard. And then that really shifted into our check volt product line, And the check volt was really a combination of the voltage indicator and the test points, kind of as a two-in-one instead of having two separate units. And that product has just, you know, gone, thermonuclear. I mean, it's been super, super successful product. And, what's incredible to us as the company building that product, sales are nice, but like we know that every one of those installed is keeping someone safe. And that's super exciting. And I know for our team and for myself, there's a lot of joy and pleasure that kind of comes from knowing that, hey, we are really making, we're really making an impact in the lives of these electrical workers across these facilities that literally build our world, right? I think oftentimes we think about just the technology, but like these companies we're working with are the world's most important companies. And like our lives as humans would be vastly, vastly different without these companies in them. I mean, whether it's companies like Nestle or Procter and Gamble or the automotives. I mean, it's just petrochem, tire and I mean, just across the board, our lives just would not be the same without them. And so we're excited to be a part of that journey. It's very easy to install. Typical install locations. It's a 30 millimeter push button knockout. Oftentimes it's going to go on the load side of an LV piece of switchgear, LV MCCs, drive cabinets, as well as control cabinets. And so we have a lot of people who put one on the line side, one on the load side, but that really depends on your lockout takeout procedure, where you're doing the lockout takeout procedure, where you're requiring verification.
Yeah, I think we should probably, for the audio audience, this device, the check volt, is not just indication, right? You actually have test points there where you can say, well, I want to be sure that there's no voltage there. Is that correct?
Yeah, correct. The voltage indication actually kind of halos around the test point, which is kind of a cool look. Everyone loves flashing lights, and so this one you actually should have like lit up test points, which is really fun.
Yeah.
Yeah, but the 70E committee has been they put this in their Annex O, which is their safety by design kind of best practices. So it's been great to get a lot of support from the electrical safety community on this unit.
If you or somebody you know needs hands-on training with Rockwell or Siemens PLCs, I want you to consider the Automation School. Not only are you going to find that we're less expensive than sending your people to the factory, we're going to be able to cover more content quicker. And we can even teach your students on both Rockwell and Siemens if you want to do a multi-day engagement. Now, you'll find all the information about my hands-on training over at theautomationschool.com/live. And if you have any questions, I want to encourage you to reach out to me. But just keep in mind that what we can do here is typically more than you'll find other places because we have more equipment. Anybody can put APLCs in a room, put APCs in a room, and say, here you go, here's a lab book. What we can do is share, well, my 35 years experience using this stuff, but also I have dozens of products from third parties we can bring in and integrate, in addition to all the vendors I've shown you on the YouTube channel and on the automation blog over the years. So again, if you want to do hands-on training affordably and you need quality instructor, please consider sending your students to me. And for all the information and to get in contact with me, please visit theautomationschool.com/live. And with that, let's go back to this week's episode of the Automation Podcast. Yeah, we covered it quite a bit over the years. One of the things that I think a lot of us run into is the fact that, my wife is, as a principal, is guilty of this as well, is that a lot of people don't realize where manufacturing happens. So my wife the other day, she was frustrated. This is probably a year ago. She's like, everything's made overseas. And I'm like, what are you talking about? We just passed 3 companies that make stuff that literally produce products. And it's, most of them are subcomponents to a bigger product. But I'm like, there are manufacturers all around you. There are massive bakeries located in the middle of towns, in the middle of, residential districts in the middle of Albany, New York, where you would never expect one to be. There are injective molding machines. There are machine shops. There, everywhere you look, you're probably passing a manufacturer and not even knowing it. It just looks like a building with no windows, right? And so they are extremely important. Whether it's medical devices or the paper we use or, A lot of testing goes into those components that go into our cars, right? Because they got to last, 40, 50 years. Even the little, window up down switches, those have to be tested, retested, and engineered so they last a lifetime. So, and if any of the audience out there, you guys have stories you want to share as well, please share them. But there is manufacturing. I remember somebody says there's no chip manufacturing in the US, not potato chips, which I do love, and there's plenty of that. But computer chips, and I'm like, I've been to Intel, I've been to Global Foundries, I've been to all these different fabs.
Micron.
We,
Yeah.
yeah, we have the Nano College right here in Albany, just an hour away. It's like we have huge fabs here in the U.S. So maybe the mass market, a lot of the mass market stuff may not be here right now. Maybe it'll come back. I don't know. But, all of the high end stuff, a lot of the high end stuff is made here locally. And even some of the not high end stuff, I've walked into plants that were just making plastic plates and plastic cups. So it's amazing what's made. And I think our audience knows that. And I would love to hear stories from them about things they have to clue their relatives and friends into about. But these are important subjects. And I appreciate you going over both the check road, the PESD. What does PESD stand for? I can't
Yeah,
remember
no,
off the top
that's
of my
good.
head.
Permanent electrical safety device.
Okay. Okay, great.
Yeah.
Yeah. And then we talked about the bulkhead connectors too. Um, Anything else you want to talk about when it comes to safety by design? Because I know it's a big topic these days.
I mean, it's there's a lot of there's other devices that we don't make
Yeah.
that that play into electrical safety by design. We have a panel outside this door here, and that's got a sequester disconnect. Okay, that's a great safety by design innovation, right? All of a sudden, the control side of that enclosure is 24 volt, touch safe. And the power side is on in the sequester. So there's a lot of ways to do safety by design. There's ways to cover over terminals for switching of switchgear. You can get a automatic kind of robotic switch so that you don't have to stand in front of the door when you're switching. I mean, there's a whole plethora of items. IR windows, for instance. IR windows allow you to do infrared inspection without having to open up panel doors. We also have continuous thermal monitoring solutions for MV switchgear. And at Automation Fair, we'll be releasing a LV monitor as well.
Nice.
And that actually, I guess one other thread to pull on there is 70E makes this assumption with electrical equipment. It's either closed and guarded or like well maintained. Okay. So one of the changes over the last kind of year and a half, 2 years has been NFPA 70B, B as in boy, is the electrical standard for maintenance and reliability, I believe, for electrical equipment. It actually tells you how you should be maintaining your gear, and that's been elevated to the same level of standard as NFPA 70E. Okay. And one of these things is just one thing that causes arc flash is hotspots. And so a loose bolted connection can cause a thermal runaway event in a pretty dramatic way. And so, even just maintaining your switchgear now has become part of that safety process, right? If you don't exercise your breaker, by the way, regularly, you don't keep your switchgear clean, you don't, there's this whole thing. You're not going to have reliable safety results on the back end of that process. And so definitely check out NFPA 70B. If you guys are kind of new into this arc flash world, there's incredible kind of consulting companies that can help you out, train you, get you started on an electrical safety program. I'd just do a shout out to Terry Becker and Jim Pollard. They're fantastic. And the eHazard guys. I mean, we've got a lot of partners in that space, and highly encourage you to be ahead of the 8 ball on both the 70B conversation as well as the 70E conversation.
Yeah, and I'd love to know from the audience too, how many of you guys are using the heat cameras, right? The infrared or heat sensing cameras. I think one popular one is the flare cameras. Very expensive, but they basically give you the heat map of your of your panel or your MCC or whatever. And what your product does is it provides 24/7 monitoring of that instead of just doing it on a, on a regular, scheduled maintenance. All right. But so very interesting. I would love to know what you guys are doing out there. Also, if any of you guys are going to Automation Fair, I won't be there. I'm actually going to a different event right now. Another very large vendor has invited me to go to an event. So, but I'd love to hear what you guys are doing if you're going to the show this year. And if you are, I'd love to know what you find out. But in any case, Drew, I wanted to talk about some of the other topics you had on the list of things that interest you, both professionally and personally. And I think we had a couple of different things. I think one of them was wearables. Another one was IoT. Correct me if I'm wrong, but
No, but absolutely. No, I guess I'll jump into the wearables first because I think, we've been talking about safety by design for the equipment. We haven't really talked about monitoring the worker.
yeah,
Right. And we're very interested in kind of this interplay between, um, between the worker and the equipment. And we think that there's going to be kind of a lot of innovation as you're able to now with new technology, be able to kind of monitor both things at the same time. And there's definitely a future kind of roadmap there for us. One of the products that we released this year is called Proxy. We released it in February, and we've seen just incredible kind of takeoff on this product. And it's a wearable, looks like this. And you wear it on your dominant hand. This senses voltage from 120 up to 400 kV. And it will light and beep, but most importantly, it will vibrate as you get close. So if you're wearing it kind of under a glove or something and you can't see it or hear it, it's a loud industrial environment, it will vibrate on your wrist. We've noticed a trend with with folks who we've talked with. Most of the time when people get shocked, they thought it was off.
I wouldn't have guessed that.
Yeah. Sean, I'm sure you've never been shocked and thought it was off. It's never happened before,
You
right?
find out quickly it's not off.
So, this product is fantastic for industrial environments. It's really targeted towards the electrician, though maintenance technicians can go ahead and wear it as well. And it connects up to your phone. You're able to go ahead and adjust some of the settings. So if you're working in a 13.5 kV substation, you can go ahead and change that setting to that voltage level, which will kind of expand the sensing radius. Or if you're only working on 480 or 600 volts, you can go ahead and drop that down into those kind of typical environments. It also has a full kind of cloud dashboard and reporting. And one thing I think is really an important discussion here for the safety and risk folks in the audience is I use this analogy a lot. Imagine you're a cardiac surgeon, but you're like the local cardiac surgeon, right? And then imagine that you're the cardiac surgeon at Mayo. Those cardiac surgeons probably have a higher kind of mortality rate than maybe what the local surgeons have in, your city, right? Because they get the hardest cases, but they're also the best surgeons and they're the most trained. And so when we're looking through the data sets that Proxy provides, it allows us to really pinpoint who our highest risk worker is. Not the person who's necessarily doing anything wrong, right? They're doing potentially everything right, but they are in the most risky job. And so that allows us to now have leading indicators of risk for the electrical worker, and we can take mitigation measures against that risk indicator. For instance, maybe instead of checking PPE once a year, we're going to do it quarterly. We're going to make sure that all their training, perhaps they need to go to some more advanced training courses. Maybe if we know that that's happening, maybe we need to make sure that there's additional people, additional person standing by, or maybe a supervisor goes out on a ride along a little bit more frequently. There's other kind of procedural things that we can do that really addresses that, that can address that risk, just so that we're providing support to those higher risk workers. I think we're all past the day of, using numbers to beat people down. I think we're all trying to really use numbers now to build people up and to be smart about kind of the risk and safety culture that we're trying to build in the facility. I don't know, Sean, what other questions might you have on proxy? I'm not sure if I might have covered it, but go ahead.
Oh, no, I just could see that, some standard procedures having to change if you, like, you may not know you were getting that close to that type of voltage prior to having this watch-like device on your arm. And being able to look at all that data over time, you may be saying, hey, you guys, we didn't realize, but you can't cut through that spot in the wherever you're working in the machine or in the plant or in the power room. You can't cut through there anymore. You're coming too close to to being close to the voltage there. I can also see too that maybe some barriers aren't acting as they should be. So maybe I don't know what would go wrong, but if there was a shield inside the enclosure that had degraded, you would know that because the sensor's picking that up. Whereas otherwise, you just look at it, it looks great, right? And so I think that by having that, by wearing that, and by having that information available historically, you can maybe even just knowing that somebody was in the wrong place, it's like, hey, you weren't supposed to be in that area. You're not rated that level yet. How come you're seeing this high level voltage um, when you're not supposed to be working in that area? So I can see that there's a lot of things it can do to keep you safe and to track who's doing what, where, and when to make sure that everything's going according to the plan, according to the way it should be, right? And if you see anything that's not on the normal that you would not expect, then you can sit down with your folks and say, hey, why did this happen? Why did you get an alert? You weren't supposed to be working on that part of the plant that today. Why did you get an alert? We saw that you came close to some high voltage. So I just think that's super interesting. And for those listening, the device looks like a watch. So that's the size of it. And so it wouldn't be too cumbersome or in your way.
Yeah,
Well,
we actually, so this year we presented at IEEE Electrical Safety Workshop. We won Paper of the Year.
nice.
On that, we co-presented with a partner in Tri-City Electric. They're a top 20 electrical contractor, heavily in the data center space, and one of our very early kind of pilot customers. They went ahead, they rolled out, I think it was like 100 or 150 bands. And for a 3-month pilot, in 3 months, they were able to catch 3 near misses.
Oh, wow.
um, Ace, and then unfortunately there was a fourth incident, and a gentleman came in contact with 480. He ended up having to spend the night in the hospital. He's okay. That day, he ended up forgetting to put his band on in the car, and so
Oh,
he forgot it in the car that day. And so there was a safety stand down meeting the following day after the incident. And, the owners and the management of Tri-City came in and said, hey, we're really, we really are trying to keep you guys safe. You got to wear these bands. And some of the older electricians were kind of hemming and hawing. And finally, the union manager got up and he goes, no, look, we're investing in your guys' safety. You will be wearing these every day. And it's really, I mean, that cost of an incident, even though it was just a single night in the hospital, between the downtime, the OSHA fines and kind of all these things, it was a $250,000 event, right? And those 3 other near misses, that would have been a $750,000. The payback in 3 months was enormous, right? By preventing any of those incidents. We also ended up winning the Showstopper award at NECA a few weeks ago, which was a total
nice.
surprise, which is really, really cool. And so it's been just great to get a little bit of like industry like validation that, hey, we're on the right track here, and people, it's cool to be able to bring technology that actually really impacts people's lives. Another kind of thing I think to think about here is it's something like 80% of injuries happen the first 2 or 3 years on the job. So, you know, when you start thinking about who to protect with some of these devices, we've seen a massive turnover in seniority in industrial facilities and electrical contractors, right? A lot of the older experienced people have left, and now there's younger people, and they just don't have the experience level. And so a lot of the units that we have help make you both more productive, more safe, but also it's more obvious, right? And so if you're new, it's good to have kind of that obvious factor.
Yeah, absolutely. And I mean, that's industry wide. We just have people like to retire when they get old. Who can blame them?
How rude! How rude!
So, yep. So in any case, I know there another topic you wanted to cover during today's show? I think we really did a good job on covering those previous two topics.
Oh, sure. So on the IIoT front, I led an acquisition in 2017 that really transitioned Grace from being a more mechanical analog electrical company into a fully digital business. Um, and we realized that there was a dramatic need throughout industry across all sorts of verticals, across all different application spaces, that they really want to prevent downtime. And in as the US is on its reindustrialization journey, we have to run these plants super reliably. The capex expenditures are really, really high, right? And a lot of the methodology for plant reliability has been either just scheduled maintenance or run to failure. And so we're just going to wait for things to fail, or we might go around on a yearly or a monthly basis and do maintenance whether they need it or not. Also, sometimes if over maintaining equipment is also a bad thing. It leads to a lot of failures. And so we went through kind of our IIoT and reliability journey. And so we released our new vibration temperature node out at Automation Fair last year. This is our VBTX. This sits out on any rotating asset across industrial facilities. We also work with OEMs that have specialized equipment, and we're able to go ahead and monitor, vibration in 3-axis plus temperature. We do a full 4A transform down on the node. We're able to get about 10 years battery life on this. What's really unique about us, though, is that with our relationship with Rockwell, we were able to develop a gateway that was Ethernet IP based. And so we're one of the only cloud optional kind of IoT companies in this space. And what we found with a lot of controls engineers is they want to go ahead and have one of these types of systems, but they want to integrate it into their PLC or into their SCADA system or their HMI screens. And so we have a AOP through Rockwell add-on profile that you can go ahead and download. And we've made it super easy to configure a wireless node network inside of that AOP. And that's been a really cool thing. And the results that we've seen have been, enormous. I mean, it's like you catch one of these downtime events and the whole project just pays for itself.
Yeah.
And it's great ROI. The other thing is that there is a safety and reliability piece together, right? There's a stat that was at one of these conferences, and it was like 80% of 80% of incidents happen during reactive maintenance. So it's like when the plant's down and everyone's feeling pressure and the COO is calling, hey, we got to get this plant running. We got to get this plant running, that people end up, just naturally taking some sort of shortcuts, and they get hurt. And so if we can be a little bit more preventative, predictive, and say, hey, like this is what's going on. We've also added in some defect classification as well, which allows you to kind of look at the data trends and say, hey, this is a bearing issue. This is a bent shaft. And so we've kind of developed a pretty unique analytics sandbox. And so that's been a really awesome kind of product line to see. And we love working with companies that have interesting applications and OEMs who, have a lot of equipment out there that they want to be able to monitor maybe on behalf of their customers as well.
Yeah, and the fact that you can integrate it on Ethernet IP is a big plus because if you have Ethernet IP all over the place, that's a great way to integrate it. I also think, and this is a little off topic, so I apologize if I get this wrong, but thought I remember an acquisition you did where you had these, because you want these sensors, you don't want to be changing the batteries on these sensors all the time, right? And a 10-year life is phenomenal, right? But I also saw another technology I believe you guys um, acquired that allows the heat differential between the actual device, like the motor, and the ambient air to power the sensors as well. Can you talk about that?
Yeah, that acquisition was called Perpetua, and that unit today it's quite a complex web of certifications because it's got all the intrinsic safety certifications.
Ah,
So that today really only works with Emerson Rosemont transmitters.
okay.
We do have it in our roadmap to kind of combine that into our nodes to be able to offer an additional power source that you don't have to go out and change batteries. The R&D team's still working,
Sure.
one of the many projects, but we do think that that's a pretty compelling, a pretty compelling piece of technology. And you know, these thermoelectric generators, I think are going to be a huge kind of game changer across the industrial facility and will allow a lot of different sensors to be powered at a much higher refresh rate as well.
Yeah.
And we're kind of excited for that future. Just hazardous location certifications are
Oh, yeah.
tough, but we've been working on it.
So, and you just don't actually sell the products. Don't you have to go along with these like a cloud-based condition monitoring solution as well for those who want that?
Yes, absolutely. So we have a full cloud-based kind of suite of all the dashboarding and analytics tools and the ability to go through and set up assets and monitor those assets. But we think that there's incredible value there, but we totally understand our customers kind of if they go, hey, we can't have cloud, we go,
Yeah.
no problem. There's a control only integration available to you. If you want to go ahead and add on the cloud later, if you want additional kind of insights, we're more than happy to go ahead and add that package onto your deployment.
Yeah, I can definitely see where there's part that's not the controls engineer's kind of gambit. Maybe it's facilities in some places. The controls engineer they don't get into HVAC, they don't get into facilities, fresh water and all that. Some places they do, some places they don't. So I could see for that kind of person who's doing the kind of, the site-wide stuff, that would be huge because they can put this on they can put that on the devices on the motors they need them on and just have it all go to the cloud. They don't have to learn anything about PLCs. Am I right?
Absolutely. I mean, it's super easy to just add additional nodes in, right? On your PLC, you would need to be able to create the visualization. You need to create the visualization in the HMI screens, right? So if you want to add additional nodes, there's a little bit of programming to be able for that to show up in your HMI. Whereas in the cloud, it's just immediate and automatic. We also will be running and releasing additional prediction models. We actually got a
Nice.
$1 million NSF grant, especially on bearing prediction. And bearing prediction is a relatively difficult problem. There's only a little bit of kind of information ahead of the degradation curve. And so you have to pick this up really at like the right point in time. And so we've been developing models and testing out, if there's listeners who want to partner with us to also help kind of validate some of that information. We're always looking for customers to collaborate with and folks who are looking to increase the reliability of their equipment.
Yeah, especially for those who are driving. Can you give the folks the best way to get in contact with Grace?
Yeah,
You
I mean,
specifically?
so go ahead and find me on LinkedIn, Drew Allen. It's my name. Also, if you want to send us an email, my email is drewa@gracetechnologies.com, or you can email sales@gracetechnologies.com as well. Someone will be in touch with you, and we'd love to chat. But connect with me on LinkedIn. I love engaging on LinkedIn.
That's awesome. Well, Drew, I'm looking at the time. Was there anything else you want to discuss in this episode?
No, Sean, I just, thanks so much for kind of what you've been doing in the automation space and your support of Grace over the years. It's been cool to see what you've built, and always great to sit down and just talk kind of product and insights of what we're seeing in the field. And hopefully we can do this again sometime.
No, I appreciate it. And, I think I have fond memories of Grace throughout the years and all those different ads. The one that I think it looked like the game operation, and then going through all the iterations as new things would come out. And just was really glad to have you on. learn about the history of the company, and learn about some of your products, which of course we've all seen here and there. And if anybody goes to Automation Fair, make sure you say hi to the folks over at the Grace booth. And Drew, again, I just want to thank you for coming on the Automation Podcast.
Hey, thanks so much, Sean.
Well, I hope you enjoyed that episode. And just a reminder, if you need any online or in-person training, please contact me over at theautomationschool.com. All my information is at the top of the website. And don't forget, if you are already enrolled in or buy my existing courses, right, you will get the new courses completely free of charge. So for instance, if you're in, PLC Basic Standard or Extended or Compact Logics Level 1 or Level 1 and 2, you're getting the new course I'm releasing next year free of charge. And if you come late to the party and you buy the new 2026 course, you're going to get the old course as well. I just had somebody today tell me they're stuck on version 20, and that's why I'm giving them the old course with the new course, is because you're going to have people out there servicing version 1 through version 30. Not everybody's going to be using 31 through 38, right? So in any case, check that out over at theautomationschool.com. They sponsored this episode, which is why I'm talking about it again. But in any case, it's a big part of my business. How I keep the lights on is selling online courses and in-person training, which I get some exciting stuff coming for that this coming year too. Also, please check out, I'm launching the new channel, the Automation Museum channel. And so please check that out. I was publishing the videos here, but I decided I'm just going to put them all over there. We've not only had some interesting people on the show, but we also interviewed one of the design engineers on the Modicon 084. That's right. What many consider the first PLC ever, yet we interviewed him. And so interesting. He's the guy who did the firmware. He's the one who made the processor, the CPU inside on the circuit board. He's the one who made that speak ladder logic. And it's been so interesting. He sent us a bunch of his notes recently that we're going to incorporate into the Automation Museum. I already have done all the research on how to do the a virtual museum, so I can scan in all my stuff and you can actually go there and look at it detailed as a 3D model. And so that research all done. Now we just need financing. So I think over 8 months we raised $200, and I want to thank the 4 people out there who donated. Thank you very much. Really appreciate you guys. You're the cream of the crop of the industry, quite honestly. But thank you so much. And if you guys want to see that that interview with the guy who designed the Modicon 084, that will be releasing on the new standalone Automation Museum nonprofit YouTube channel and website. I'm hoping over the holidays I'll have some time to work on that, but try to work on those things on Sundays because it is a nonprofit. But in any case, I want to wish you a happy holiday. This is it. This is the last episode for this year. We already have several episodes ready for next year, and probably skip the first week of the year. But we have just a bunch of interesting people. I have interviews from when I was at the Schneider event. I've reached out to a bunch of people at Rockwell. I got to reach out to my friends at Siemens. I know they had a reorg, so I don't even know who to talk to anymore, but wanted to learn about new things there. Of course, we've had Siemens on quite a bit this year, talking about all their great new products. And I think there might be a new version of TIA Portal out. I know there's a new product, a new version of CCW. Actually, it's called, I think, Design Workbench, that's replacing CCW, but it's not ready for prime time. We'll talk about more of that, maybe even before the end of the year on the on the other show, the Automation Show, or Tech Tips or Tech Talk. But we're going to keep that going too into the new year. We get some new websites planned. We're talking to sponsors to sponsor this show, and maybe I can offload some of the editing to somebody else, because honestly, it takes a long time editing the shows, not just setting them up and recording them. So in any case, especially when they're sponsored, we try to go through it with a fine-tooth comb. But yeah, a lot of exciting stuff coming for 2026. I'm looking forward to it, and I hope you guys are as well. And just want to wish you all a very happy holiday, Merry Christmas, Happy New Year, and we'll see you back here on the Automation Podcast in early 2026. And with that, I want to wish you all good health and happiness. And until next time, my friends, peace.